Ever stop and think about all the data in your life? From your bank account to that airline ticket you just booked, our whole digital world is built on information. But where does it all go? How is it all stored, kept organized, and most importantly, kept safe? Well, today we're pulling back the curtain on the powerful software that makes it all happen, the Database Management System, or DBMS for short. All right, so here's our game plan for this explainer. We're going to start with the absolute explosion of data that's all around us. Then we'll take a little trip back in time to see the old way of doing things. Think of a messy digital filing cabinet to really get why databases were such a revolution. After that, we'll unpack the superpowers a DBMS gives us, take a peek at the architect's blueprints they're built from, and finally, we'll see how these systems are quietly running pretty much everything in your life.
Okay, let's dive right in. First stop, just trying to get our heads around the massive amount of data we deal with every single day.
No, seriously, think about it for a second. Every time you book a flight, sign up for a class, or just add a new contact to your phone, that information has to go somewhere. It doesn't just poof into thin air. So where does it live? Well, the answer to that question begins with the database.
So at its heart, what even is a database? It's really just a collection of related data that has some kind of built-in meaning. Your own address book is a perfect example. It's not just a random jumble of words and numbers. The names, phone numbers, and addresses are all logically connected. Or you can scale that way up to something like a university's database, which keeps track of every student, every course, and every professor. It's the organized structure that brings order to all that information chaos.
But things weren't always this organized, not even close. To really appreciate why these powerful systems are so crucial, we've got to look back at how things used to be done, which was basically a digital version of a super messy file cabinet.
You know, before the DBMS showed up, information was just dumped into separate standalone files. Imagine a university, right? They'd have one file for student registration, a totally separate one for grades, and maybe a third one over here for billing. Each department's computer programs would just pull data from their own little pile of files. It sounds simple, but trust me, it was a recipe for some huge headaches.
And this old way of doing things created a total mess. First, you had data redundancy everywhere. The same student's address might be stored in 3 different disconnected files. And what happens if you update it in one file but forget the other 2? Boom, you've got data inconsistency. It made sharing information a nightmare, it was hard to keep secure, and it was just a disaster to manage. A DBMS, on the other hand, fixes all of this by giving you one thing: centralized control. So that's what a DBMS is. It's the software that acts as the official gatekeeper. It's a collection of programs that lets us define, build, tweak, and share a database across tons of different users and applications all at the same time. It's the manager that finally brings some order to the chaos.
Let's just quickly break this picture down. See, up at the top, you've got the users and their apps, all making requests. Way down at the bottom, you have the actual physical database, where all the bits and bytes are stored. And the DBMS software? It sits right there in the middle, like a smart traffic cop. It intercepts every single request, figures it out, and makes sure data is accessed and changed in a controlled, secure way. It's the brain of the whole operation. And having this central control isn't just a minor improvement, it's what gives a DBMS some incredible superpowers that totally change the game for how we handle information. First up, it tackles redundancy. The goal is to store each piece of information, like your address, in only one spot. That saves space and, more importantly, keeps things consistent. Next, it enforces security, letting you set super specific rules about who can see or change what. It also allows for sharing, so lots of users can be in the database at the same time without messing things up. And maybe most importantly, it provides backup and recovery, so if the whole system crashes, your data is still safe. So the crucial takeaway here is this. Just by moving data from a bunch of separate files into a DBMS, we suddenly get this whole toolbox of features to manage everything in a really strong and efficient way. It was a complete paradigm shift. Okay, so we've covered the what and the why. Now for the really cool part, the how. How do you actually design the structure for all this information? Well, it all starts with a blueprint. And that blueprint has a name. It's called a database schema. You can think of it as the skeleton of the database. It lays out how everything is organized and how all the different pieces of data relate to one another. And it's designed by a database architect before even a single piece of data gets put in. Now, to handle all this complexity, modern databases use this really smart design called the 3-schema architecture. The whole point is to separate how users see the data from how it's physically stored on a disk. This creates different layers or levels of abstraction, which makes the whole system way more flexible and easier to manage in the long run.
So at the very top, you have the external level. This is the layer that you and I see and use every day. It's a specific, customized view of the data that's designed for one particular task, like the web page you use to book a flight or the interface on your banking app. At this level, all the complicated stuff happening underneath is totally hidden from us.
Okay, go one level deeper, and we hit the conceptual level. This is the master blueprint. It describes the structure of the entire database, all the different data types, the relationships between them, and all the rules. This is the world where database administrators and programmers live and work.
And then, way down at the bottom, you've got the physical level. This describes all the nitty-gritty details of how the data is actually stored on hard drives. We're talking file structures, indexes, all that low-level stuff. This layer is all about making things run fast, and it's completely hidden from pretty much everyone except the DBMS itself. Now, to build these blueprints, architects need a special set of tools, right? Well, in the database world, those tools are called data models. They give you the concepts and the language you need to describe the structure. Let's take a quick look at the two most important ones. First, you have the Entity Relationship Model, or ER model for short. This is what you use for that high-level conceptual design. It's just like an architect's first rough sketch. You figure out the real-world entities you care about, like students and courses, and then you define the relationships between them, like a student enrolls in a course. But once you've got that conceptual sketch, you need to turn it into something practical. And that's where the relational model comes in. It's by far the most popular data model in the world. It takes those abstract ideas of students and courses and organizes them into simple structured tables with rows and columns, kind of like a spreadsheet on steroids. Each row is a unique record, and each column is a specific attribute. So we've gone from total chaos to organized tables, from messy files to architectural blueprints. Now let's bring this all home and see where these powerful systems are actually working in our everyday lives. The answer is pretty much everywhere. Seriously, your bank uses them for all your accounts and transactions. Airlines use them for every reservation and flight schedule. Universities use them for student registration and grades. Any online store you use relies on them for customer and product data. Companies use them for all their employee and payroll info. They are the invisible, essential backbone of our modern world. So, from the simplest app on your phone to the most complex global corporation, database management systems are the things that bring structure, security, and efficiency to our data. They are the quiet organizers of our entire digital world.